Good afternoon, and thank you everybody for showing up. My name is Lorenzo Tessiore. I am the developer manager with the .NET Micro Framework team. And today we are going to talk about how the .NET Micro Framework enables intelligent devices to fit in the managed code embedded development offering of Microsoft and of the developer division. So let's start from some background. Why devices and why are we interested in devices? Devices have been in the few years back, a very innovative market. And they are becoming more and more intelligent and more connected to our lives. As this is happening, there is a strong need for devices to fit better, to fit more smoothly and nicely into the usual development patterns that developers are used to. And this is particularly noticeable in the 32-bit segment, which is similar to the processor, more similar to the processor that we use on the desktop, which is also the fastest growing business in the market segment for devices. In fact, 8-bit and 16-bit devices, all analysts agree that they will continue to exist, but they will keep very much flat over the few 5 to 10 years. With all these needs that devices do have and all of this activity around devices, we notice, though, that in the industry there is still not any winning development platform, and that whatever is available to the developers is fractioned into a myriad of small offerings, none of which are extremely modern, or they do provide a very extensive set of features that could satisfy possibly any need. Also, devices are still today, generally speaking, a territory for native programming, and that makes the code more difficult to port, generally speaking. Least but not last, there is always, very often I would say, the need for embedded development in devices fields for specialized programming skills. There is a need to hire experts for some kind of sensor or some kind of communication protocols. There are few standards available, and this could represent a cost, especially for smaller companies. So how do we plan to attack this set of requirements and challenges is the subject of this talk. And we are going to introduce the micro framework as a solution we're considering to solve these problems. And we are going to explain how the micro framework acts as a bridge between what we call the desktop programming skills and embedded development programming skills. We are going to give a quick overview of the architecture of the product. We are going to see how it fits into the overall embedded offering of Microsoft and what kind of devices you can actually address with the domain micro framework. Then we are going to go through a demo, and then we are going to take a deep dive into our tool set and then see how you can get a hold of the micro framework and what's up with our latest announcement about the community and how you can get a hold of the source code. So let's start by placing the micro framework on the devices universe. Where does it fit? Well, in very simple terms, let's imagine that we have 2 coordinates. And one of the coordinates is the device power in terms of CPU computational power and in terms of memory displacement. So how much RAM, how much ROM, how big is the device. We will put that on the x-axis and go from small to large. We see that we have several different examples of devices. So we're talking about MCUs, microcontroller units, and for example, on the lower end, we have processors like ARM7s or the newest Cortex-M3 or the SH2 from Renesas. Then as computational power increases, we see instead processors like ARM9 or the Cortex-A8. where, for example, we have applications like smartphones, and then growing, we have more complex and powerful devices, such as the Atom, and there we start talking about very advanced smartphone or netbooks and PDAs, up to laptops. On the y-axis, instead, we can place another coordinate which talks to what the device can do and what the libraries what libraries one developer can expect to find in the market to program those devices. Therefore, we call that device capabilities. So given this very simplified marketplace, we can observe that at the very top, Microsoft has a very well-known offer, which is the .NET Framework, which can run on OSs like Windows XP embedded. So the .NET Framework is a natural complement to the XP embedded OS, which can run with or without the framework, of course. Going down in the device continuum, we found the Compact Framework, which can run on top of OSs like Windows CE. And it can address devices like smartphones, but also devices like feature phones. Then going to the very low end of devices, we find the .NET Micro Framework, where our main focus and target are smaller devices like ARM7 and ARM9, but we can extend and we can certainly run on all the other devices as well, as long as it makes sense. What is the .NET Micro Framework then? The .NET Micro Framework, like the Compact Framework and Windows CE, is a re-implementation of the desktop CLR targeted to embedded devices. The .NET Micro Framework is a toolchain for those devices that cannot run Windows CE and the Compact Framework because they are not powered with enough hardware resources in terms of computational capabilities or memory. To understand what we're talking about, it's nice to give a few symbolic numbers. Our full feature set, including sockets, including touch support, web services, HTTP support, and all the main libraries from the desktop, is contained in less than half a megabyte of code size. And we can run a fully featured managed application in 1/4 of a megabyte of RAM. In comparison, Windows CE and the Compact Framework, that allows you to run managed code on devices as well, will require around 10 megabytes of both ROM and RAM to do the same job, of course, with the better performances and with the more power. The typical price point of the MCU that we target is between $2 and $10, therefore very inexpensive. And we do support natively a quite wide array of instruction sets that allows us to run on most commercial processors, and among the others, the ARM, the thumb, and the thumb2 instruction set for ARM processors, the SH2 and SH2A instruction set for the Renesas processors, which is our latest addition, and the instruction set for the Blackfin processor from Analog Devices. It's important to remember this is an entirely independent code base engineered to target these small devices explicitly. This is not a rework, or this is not the Compact Framework. So how do we bridge the gap between desktop programming and devices, embedded development for devices? Well, we do it starting from the top of the toolchain, and therefore we do it by bringing the power of the toolchain that Microsoft uses on the desktop to the embedded devices. Our SDK is an installer that plugs into the latest version of Visual Studio, therefore Visual Studio 2008 Service Pack 1, and that allows to program devices completely using managed code. We do support interoperability for those special needs of people that might need a different device driver or some advanced functionality, and they do need to write some native code. And what do we offer standard in the SDK package is a subset of the .NET Framework libraries that we inherited from the .NET framework for the desktop, but we did rework to tailor it, to make it more suitable for embedded devices. We are going to see later in the details what is that we gave up and what we added. This is an overview of the architecture. It's a very simple monolithic architecture, but at the same time is also very flexible. The .NET Micro framework is fully modularized, so you can mold the set of features that you are deploying in a single device image based on the code size that you want to achieve and how many features you want to include in the device image. Starting from the top, you have the managed application. The managed application is developed entirely in Visual Studio, is entirely managed code, and is developed using our SDK. And it relies on the application services and the managed libraries that do make up our object model. In the managed libraries, you find those basic facilities that are threading, collections, collection, reflection, system.NET namespace for HTTP, OBAT socket as well, XML parser, and a lot of other features. In the application services, you find the more advanced features, like, for example, our graphic model, which is based on WPF, our web services support, which is DPWS, device profile for web services, and is a subset that implements a standard based on the WS star specification. And you also find advanced features like, for example, touch panel support. Underneath the managed libraries, you find the managed runtime, which is both a managed runtime and also an executive. As you notice, there is no OS in this picture. The OS is only optional because you can run the micro framework on top of an OS if you want, but it's probably the system is more suited to be run directly on the hardware through a platform abstraction layer and a hardware abstraction layer, which is the only device-dependent code that one needs to replace to port the micro framework on whatever processor. As you notice, we have two tools, one of which we call the SDK, and the other one the porting kit. The SDK is an installer for Visual Studio that enables to code the managed application, and it can target both devices and a standard emulator seamlessly, so that one can prototype the application on an emulator without having to deal with the hardware right away. So this is a big advantage if the hardware is still not available, and also makes development easier when the hardware still is not completely stable. And the SDK is also usable from Visual Studio Express Edition. The porting kit instead takes care of addressing the lower part of the stack, and therefore is a tool that one can use to code the device drivers, which in the broader sense means porting the micro framework on a completely different processor, rewriting all the device drivers and running on whatever processor you need to address. Also, with the porting kit, starting with the 4.0 version, we are giving away the source code for the object model and the runtime, so that one can potentially customize the runtime and the object model as it pleases. We have seen before that embedded development is a very fractioned set of requirements, and customization is, generally speaking, the name of the game. So, given this architecture and tool set, I wanted to give you a quick demo so that you can see more closely what we are talking about. So we had some problems with our Wi-Fi support. We couldn't actually get it in the network, working in the network here in LA. And we're going to see a subset of the demo. The original demo was built around a very common scenario that involves retrieving humidity and temperature data from two sensors based on one on I2C and the other one on the SPI bus. Those are two very popular buses in embedded development, very low level, and they just transfer. The SPI bus is like a shift register. It just moves bytes in and out. and requires a chip select to actually address the sensor device. The I2C bus is a little smarter. It can handle addressing. So you can talk to whatever device on the bus by sending out on the bus the address of the device you want to talk first and the start bit. You understand, though, that these are very far from a socket type of communication protocol or HTTP or web services. So they are typical embedded development type of buses. And we connected those two sensors to a board running the .NET Micro Framework, which is provided with a radio chip that runs the 82.15.4 communication protocol and communicates the sensors, the data about humidity and temperature, to another board running the .NET Micro Framework, which has this time an LCD, the same radio chipset to talk 82.15.4, and then over a web service, DPWS, therefore WCF, therefore basically over SOAP and HTTP, communicates this to the backend, where we can visualize it in a Silverlight application. Unfortunately, the Wi-Fi part, we couldn't get it working, but I will show you the code. And we can now go to the demo and show what the code for this application looks like. So I will start with showing you some of the code. As you see, this is Visual Studio. It's the same Visual Studio that you would use to code any desktop application, and you would start coding a micro framework application the same way you would do for the desktop. File, new project. Of course, I installed already the micro framework SDK on this machine. The only requirement being having the framework 3.5 and Visual Studio. I would say File New Project, and since I installed the SDK, under the C#, the Visual C# wizards, I have the Micro Framework wizard, and I can create a class library, or a Windows application, or a console application. I can even create a device emulator, and we are going to talk about that later. I already did that, and therefore here I have my project, in which we find one application and one class library, the class library being the radio chipset support, the XB radio chipset that implements the 82.15.4 protocol. I put it in a library because I have to share it between this solution and the solution and another solution. So this is what the code looks like. We have here a pretty nice example. In this main method, we do create the radio for the XB chipset, and if we go and explore how the radio works, we will quickly find out that the radio works on a serial port, which I do create in manage code, and then I use, this is the same serial port that you find in the .NET Framework for the desktop, and then I use to talk to the chipset, sending commands to enable the radio. We had also a property page when we install the SDK, and in the property page, in the Micro Framework property page, one can select to which device to deploy to, and that can be either the emulator that is extensible. Now here I have the standard Microsoft emulator, or it can be any transport protocol of your choice, USB, serial, or TCP/IP. The board that I'm using today, incidentally, supports USB. So I select USB, and I see that I have two boards attached to my, we do some auto discovery. We do the same for TCP as well. I see that I have two boards attached to my laptop, and I choose the one that I want to deploy this application to. The name are customizable. I go back to my program.cs file. I set a nice breakpoint there, and I do start the debugging like I would do for any desktop application. At this point, Visual Studio and the SDK are connecting to the board, checking what assemblies are running on the board, seeing what is the differential of the assemblies that they need to deploy. We don't deploy the same assembly twice if it's not necessary. Then they are starting deploying the assemblies, talking over the debug API on the board, and eventually we will start the debugging. So you see that at this point, there is no particular embedded development knowledge involved into coding this application, and we will quickly step over how a driver for something like a humidity sensor looks like. We can do that while we wait for the deployment to finish. So our temperature sensor, humidity sensor driver works over an analog to digital converter, which is manufactured by Analog Devices. Is the model 7993, which is available commercially off the shelf. This is the class where I encapsulated the functionality of the analog to digital converter. And you see that he uses a I2C bus to talk back and forth to the converter. There is an output port, which is like the I2C bus part of our standard object model, that I need to start the conversion, to tell the converter to go and do the conversion of the humidity. And then I have the actual implementation, which is again code that I wrote. We can take a look at. And the conversion, here there is some nice enumeration to make the code more pretty. The conversion has only one method, which is acquire, and it does nothing but writing some commands over to the I2C bus and reading back the data. And this is what the driver looks like. We create a read and write transaction. We send it to the I2C bus. We execute it there in the I2C bus, and we channel back the result. We do some exception checking, some parameter checking. Here the deployment is taking a little longer than expected, because probably I'm keeping the line busy to the device. Let me retry it. It's still actually doing it. Give me just a second to get it in line. Probably it's better to just start another instance. I actually finished. Let me bring up, maybe it is in progress, yes. Okay. Let me reboot the device just because. Shut down this one. Okay, we can restart the deployment. Of course, the second time it goes better, so we see that it's now trying to connect. And the deployment now succeeds, and we are actually debugging the actual device right now, and we can proceed like if we were debugging any desktop application. So I'm doing some F10s here, and I can see all the support, for example, for the local variable. If I want, I can, now I jumped into this method, which creates the XB class, and is going through a rather long interaction with the radio chip to initialize it, which is probably why it wasn't coming back before, because it was going for the same iteration. It now did it. I see here in the local variables, I have my XB instance variable. I can inspect the locals. I can inspect how many threads are running on my processor. I can see everything that I can see on a normal desktop application. At this point, I will let the application run, but before, I'm going to go in my humidity sensor driver, put a breakpoint in our acquire methods, like, for example, here, and also in our analog digital converter, run the sample, and we see here that, for example, we hit the breakpoint that we just placed, We are still on the main thread where this breakpoint is overreaching. Now, for example, you see here that we have two threads. And this is actually a thread of a timer that we start to periodically poll the temperature sensor. And you see it's a timer callback, and send the data to another device over the 802.15.4 network. I'm going to connect now that other device. This one comes with the LCD, and I can show it to you on the screen over here. Is booting up. This guy is going to try to acquire a static an IP address, and unfortunately that will not happen. You see that this device, they are both manufactured from our partner GHI Electronics. They all come with support for 802.15.4. These are the two chipsets that talks to each other over the radio. This device also has a Wi-Fi support, which obviously is still in beta. It is a device with an LCD, rather generous. And instead, this one is a headless device, ideal for applications like sensors. This is actually, if I can put it more here, this is actually the temperature sensor, the humidity sensor. And the processor is instead down here. You can see it later. And it's self-contained. It's a ARM7 with embedded 512 kilobytes of flash and 96 kilobytes of RAM. The price of this processor is around $7 to $8 in quantity, and it makes it ideal for a sensor-like application where you do not need to be an embedded developer to actually integrate that into your application. So I'm running the code. In the meantime, this guy came up. You see that he's receiving the temperature and the humidity over the radio, showing them up on the UI. And it supports touch as well, where, for example, I can go here and modify the thresholds of my wine cabinet application monitoring, go back to the main monitor, and here at this point, if a threshold was exceeded, we would send an alert to the backend, and we would have seen it on the Silverlight application, which we cannot do because we couldn't get the Wi-Fi working, unfortunately. So this scenario that we show right now is very typical, actually, in a lot of other scenarios that are popular at this time. And one of them, for example, is energy management, which has a very similar type of deployment and displacement of resources. In energy management, there is a need for a very powerful backend that needs to process a lot of data, but those data do come from smart meters and devices that are very similar in concept to the temperature sensor that we just saw. Or maybe just getting an event that your electric car is now at home and is recharging from the grid. So all of those type of devices, the ones that are on the side of the client, they are devices that are suitable for application of the .NET Micro framework. And one of the things that the industry is discussing at this time is whether those devices are actual client or servers. In the case of the car plugging in the grid, when you need to recharge it, there might be a client. But in the case of the temperature sensor, there might be the server. And with the micro framework programming model, we do support both of those scenarios, both client and servers, and we're going to see that there are some powers trade-off that you can do there, which we enable to program in managed code. Another very concrete examples that we can see is actually deals with the actual garbage collection. This is a project that our colleagues at the Microsoft Research Laboratories at the Polytechnic of Torino developed. And it was developed for the Venice municipality. In Venice, it's very expensive to actually pick up garbage. So the municipality is actually thinking about charging per amount of garbage produced, and they are looking into a system when they have RFID tags on the garbage bins. The users get to the garbage bin, they swipe the tag. There is, again, some kind of radio protocol, in this case 802.15.4, which runs the micro framework, and there is an MCU, which is storage capability. We do support the system I/O, we do support file system, that registers the usage of the garbage bin. When the garbage truck walks by, he has the same micro framework device, which unloads all the data about the usage, and then it uploads it to the backend while is continuing his trip for the streets. So you see that in this scenario, there would be the need, like in the temperature application that I just saw, there would be potentially the need to be radio protocol experts, but also sensor experts, and integrate very small devices like RFID sensors. But with the micro framework, you can still leverage your desktop skills and do all of this in C#, including the radio protocol. Let's take a deeper dive into the tools that will enable you to become embedded developers. We saw that there are two main tools that we do provide. One is the SDK, and the other one is the porting kit. The SDK is the most interesting tool to get started. It contains absolutely everything that you might need for a very, very long time, and it will enable you to actually program all the demos and scenarios that we have seen so far. What's inside the SDK, and what is the SDK? It's a very small MSI package that installs on top of Visual Studio 2008 SP1. It's in our roadmap to keep in sync with the next release of Visual Studio. It contains all of our custom tools that do process the assemblies produced by the managed compilers that do come standard with Visual Studio. They do process them into our native format, therefore compressing and making it more efficient for the scenarios that we are targeting. The Visual Studio, our SDK comes with the project wizards, which we saw, and with the full object model. But it also allows you to program extensions to the object model, and also interop extension to the object model, therefore assemblies that do native calls to the runtime. There is a whole set of satellite tools, like, for example, our font editor to produce other fonts. We have our own special type of font format. So we do provide font editor tools. We do provide device diagnostic. And we do also install a help inside the help system of Visual Studio with the SDK installation. The other tool that we do provide is the porting kit. The porting kit is everything that the SDK is not, and therefore it deals mostly with the native code part of the system. Our expectation is that 99% of the user will never need the porting kit, because they will always find the processor available off the shelf that we do already support, and they will use that processor. But if you need to add drivers, support a processor that we still do not support, or run the micro framework on a processor that runs an instruction set that we do not support, like, I don't know, MIPS, then you need the porting kit. And you can get the job done with the porting kit and the SDK on top of it, and standard native compilers, such as ARM RVDS distribution, the Kyle MDK, which is very popular, or GCC, which comes for free and we do support. Or if you're targeting the Renesas offers of the SH processor and the other processors they have, you can use HEW. If you're targeting Bluffing, you can use Visual Studio, Visual DSP++, which is their developer environment. The porting kit is basically a WinDDK-like type of tool. It's a build system with all of our native code, which compiles automatically, and it also comes with a very advanced wizard that helps you to take the samples that come with the porting kit and clone them and modify them. In fact, the .NET Micro Framework, and here we see a bigger picture of the stack, is a completely modularized system. All the features are connected from the object model down to the device drivers by a dependency description language, which is XML-based. And when you need to remove or add features to your device image, you just have to choose those features in the wizard that we provide with the porting kit. we auto-generate a set of build files, which you can then build to get a device image which only contains the code that you need. This helps us keep the code size down to a very minimum. And to give you an example, in the demo that I showed before, we were running the microframework on a processor that had 4 megabytes of RAM, but we were also running on one that has only 96 kilobyte of RAM. Obviously, the processor with 96 kilobyte cannot support SSL. But if you need that, you will be willing to step to a more powerful processor. You see that in the application services layer is where the most interesting stuff is, and it's where we do actually work transparently with regard to our interaction with desktop application. There you will find the DPWS, which is the device profile for web services, which is basically a subset of WCF. You will find HTTP with SSL, advanced graphics, and touch panel. So what does the programming model look like? Well, the .NET Microframework programming model is engineered to be as compact as possible, for obvious reasons, and to be power-friendly. So everything that we do, from the device driver up and in the object model, it's always event-based. For example, I said before, your device can be a client, can be a server. For example, in the temperature sensor type of scenario, you probably want your device to be a server, to be a client if you're really striving for to save as much power as possible, and maybe you want it to wake up once every 10 minutes, take a measurement, send it over. But if you want to optimize the bandwidth usage, imagining an energy management type of ecosystem where there are millions of those devices, and those guys are scared that they are back-end SQL servers, so they will be backed up with too much information, then maybe you want to have your device acting as a server and being able to poll it. So if a device is a server, it has to be on all the time to receive the request. That means that it will not last long on battery power. But our system is engineered in a way that we put automatically the processor to sleep, to whatever sleep level the user envisions, and we will automatically wake up on interrupts, on interrupt requests that are specifiable by the user in managed code. Let's take a look at this very simple class, which I call battery server. The background here is that, so let's suppose that I know that I will have a request coming on the serial port that I want to process at some point. But in the meantime, I want to sleep and do nothing at all. What am I going to do? I am going to have this battery saver class with one very simple static method which uses a serial port instance, takes the serial port instance and subscribes an event handler to the data received event handler of the serial port. Then I go to the Power State API and I say sleep until you have a serial in event, which means something arrives on the serial port, and go to the deep sleep mode. The processor will stop doing anything, only the RAM refresh will actually keep running because that is where our managed application state is. If you have a processor with the static RAM, that is very little power. And then when the serial port interrupt at the native level will come in, without the managed code programmer doing anything, the event handler will be invoked, so you can do what you need to do, and then the processor will happily go back to sleep again. So this is the type of programming model that we encourage, and let's see it in more details in the layers, communication and messaging layers in the upper layers of the framework. We said that we do support HTTP. We support HTTP with SSL using X509 certificates, and we do support the v11 version of HTTP. We do support chunking and keep alive, which is essential for web services. In web services, I talk about DPWS. I don't know if everybody is familiar with. That means the device profile for web services, and it's basically a subset of the WS star specifications, and in particular, WSDL 1.1, SOP 1.2, WS addressing, transfer, discovery, and eventing, which means that your devices based on the microframework are discoverable, and they do also support metadata exchange. Therefore, you can query our devices to know what they can do. They will send you back basically the WSDOR. We do have, for DPWS, a code generation tool, and that is a pretty cool feature because our code generation tool, they work the same way that SVC util works on the desktop. You can start from a desktop application that runs WCF and write a service contract. You can have a WSDOR, or you can have just a DLL. You give it to our MF SVC util utility, and it will automatically produce the code for you to marshal and unmarshal the data, so that you just have to code the event handler of the implementation of your web service interface, exactly as on the desktop. We are compatible with the WCF HTTP binding, WS HTTP 2007 binding, which means that we do transport, we do transmit SOAP over HTTP. We will look into the next version to optimize for bandwidth. We do support wired and wireless. We do support wireless for our partners with 8211, and we do have a full stack for 82.15.4, provided at the source code level in the porting kit. What do we do for UI, which is the other big ticket to program these devices? We wrote our UI support following the WPF trail. We do support the basic layout controls and the basic layout like stack panel, canvas, and in canvas we do support inking. We do have full touch panel support, and we support the basic controls like test, scroll viewer, list box, and many other. We do have the same event routing philosophy that WPF uses, therefore tunneling and bubbling, and we do have the same dynamic layout policy, layout philosophy. So it's, you can do pretty cool things with our WPF support. We do not support XAML because that would be too much for our embedded engine. But all the rest that you know about WPF, you can certainly apply it to our object model. There is one important news about the v40 version of the .NET Micro Framework, which, by the way, we shipped yesterday. And the news is that we are changing our business model. With the version 2.0 up to 3.0 SP1, we had a license-based revenue model, but that wasn't really working with embedded devices. That is too much fractioned field. Everybody has different exigencies, and there are too many requirements that we would need to handle. So we thought that the best way to go about this would be to share actually the source code, and therefore the 4.0 version, as of yesterday, is available with the object model, the runtime, the device drivers, everything that we had under the Apache 2.0 license. This means that, thank you, you will be able to look into the CLR, to customize it, to augment the object model, to recompile the CLR and the object model for a different instruction set that we don't support autonomously. There is a concern, there is a potential concern with this, which is that we are not going to provide support, but that is actually not true because Microsoft will provide support for the last version of the framework. And on top of that, we will move forward and set up a community around this code base, and we will talk about that later. There is a noticeable exception that I want to mention right away. The TCP/IP stack is not written by us. We licensed it, and therefore it's only available in binary format. And the usage of the TCP/IP stack comes under a different license whose only limitation is that you use the TCP/IP stack for the .NET Micro Framework in a .NET Micro Framework product. So you cannot just use it for something else. There is also some crypto code which comes in binary form, and it's a very limited crypto code, basically some asymmetric and symmetric encryption, the classical DES and RSA. And if you want the source code for that, I'm sure that it's like a 3 days exercise, probably even only one. Otherwise, you can use the one that we provide standard for the instruction sets that we do already support. What are we going to do with this code base? And how are we going to get advantage of the Apache 2 license? We understand that it's a license which is very well accepted by the community. People are familiar with it. It allows pretty much anything. So we thought that we would set up a community where Microsoft would act as a coordinator and as a leader. We will choose members from the community as other leaders, and we are inviting everybody that wants to join the community to contribute code, customizations, additions to the object model, to the runtime, to the drivers, a new port for a new processor, or a new object model for a better 82.15.4 support, or for a better Wi-Fi support, or a different scheduler for our managed threads that is more real-time. Whatever you might think of, anything that will be interested, we go through a process of selection, and we might end up being included in the next version, which Microsoft will craft and support. So anybody is welcome in participating to whatever extent they feel comfortable to, and we are perfectly fine with just people taking the code and autonomously doing great products with it without our help. So what did we add for the 4.0 version that shipped yesterday? We actually made a pretty outstanding number of additions, and I'm very proud of putting all these features in this first version that is shipping after our move to the developer division. We exposed HTTP and HTTPS, therefore over SSL. We basically extrapolated the HTTP support from our DPWS stack, from our web services stack. And in the details, you will find web request, web response, and HTTP listener, and all the satellite classes you are used to. We have a strict versioning support, because with the community, there will be a lot of additions, and you want to be able to know what assemblies you are loading and running on your device. And now you can do that with a very extensive versioning support. Let's remember that the microframework supports dynamic assembly loading. So you will be able to bind and link specific types into your application and be selective about that. We do also have up-domain support. We moved the XML parser down to the native code level, so that now our WCF, our DPWS stack is much faster. We perfected our graphic support, our touch panel support, and our inking support. We added the power level control, so now the developers have control over the hardware interrupt sequence and the sleep patterns of the device, which is the small piece of code that we saw before. We added a time sync protocol so that a device can work in a cloud-based scenarios, can work efficiently time-wise in a cloud-based scenario. We have added support for arbitrary display size, so now there is no more size limitation for the display. If you want a huge display, you are welcome to use that. It's going to cost you some more RAM memory. And we are adding a lot of support for new chipsets. And noticeably, Atmel included yet another sample in our porting kit. Now they also support the SM9RL, which is ARM9. NXP contributed a ARM7, the 2478, and we are very pleased to welcome in the family Renesas with the support for the SH2, which is yet not available, but my feeling is that you're not going to have to wait too long. We RTM yesterday. Therefore, all of this is available on microsoft.com/downloads, and you will find there the SDK and the porting kit. So what are we going to do next? Well, the community will have a word in it, but this is what we think it's a priority right now, and we welcome your feedback on that. So obviously, we want to keep in sync with Visual Studio 2010, therefore making it easy for everybody to move forward in the usage of their development tools. We will add support for big endian processors. Most likely we will have an open source TCP IP stack so that there is no licensing problem anymore. And same goes for cryptographic support. We obviously have our eyes on wireless and connected to wireless and to remote debugging and firmware update. We are looking also into adding firmware update, logging, and diagnostics from remote, which we think that for scenarios like energy management are very appealing features. What are the resources? Where do you want to go to get the .NET Micro Framework bits and start playing with it? Well, as you probably already understood, the .NET Micro Framework is more of an ecosystem rather than just a development platform. There are silicon manufacturers that write device drivers that port our platform on their ports, and they write device drivers with the porting kit. There are object model, addition to the object model, there are end-to-end solution, development boards, such as the ones of our partner GHI Electronics and Device Solution and SJJ. And everybody is participating. Also, some partners can also assist anybody that wants to add the features to drive to an end-to-end solution that starts from one of their ports and goes to a very specialized device and maybe just makes it smaller or more efficient or less expensive. You can find all the information about the ecosystem and about our partners on Microsoft.com, NetMF, from where you will also be able to download the SDK, which is the ideal starting point for playing around with the .NET Micro Framework. Several of our partners are development boards providers. Some of the development boards cost under $100, and they are pretty well featured. So with $100, Visual Studio Express, if you want to play with the porting kit, you can use GCC. You get to play with the full runtime and the object model. So as I said, the RTM version is available yesterday, and we are waiting for your feedback, especially around the community and the feature set. And if anybody has questions, now you're welcome to ask right now.
The IP stack, is it version 6 or v4?
It's v4 only. We are looking into an open source IP stack that also provides a version 6. And the reason why we're doing that is IPv6 goes well with 82.15.4 when you use 6LoWPAN.
Is there any thought into the mix architecture?
Not from our side, but you are certainly not the first one that made this requirement. So if you can log your requirement on our forums, we are certainly taking that into consideration. Yes?
On the ARM side, I was wondering when you go into a debugging and step mode, is there support for JTAG, or is that done all at the
No, it's all done at the level of the runtime. There is an API which is based on the USB transport or the serial or the TCP IP transport. You are talking directly to the runtime. Therefore, you don't need to have a JTAG. You just need to have a USB cable or an Ethernet cable. And that is another piece of the tool chain that you don't have to buy anymore.
One other question.
Sure.
On the ARM side, how do you see the IAR compiler? Would that be a problem using the porting kit?
Generally, we added lately several compilers, and I have to say that we rarely encountered any problem. The only thing that might be a little quirky is things like templates, C++ templates and that kind of things. But usually, we can port a new compiler in a matter of 2 or 3 days. So I don't have experience with that particular product, but I wouldn't be afraid of trying. Yes?
Any memory limit regarding upper limit?
Interesting question. Our garbage collector is a mark and sweep with compaction on allocation of specific types, like, for example, arrays or bitmaps. We do not compact the heap if you allocate a string of 4 bytes. If you cannot find 4 bytes, we just assume that you are not going to find them even after compaction. Anyway, that said, mark and sweep is linear in time with the displacement of the memory and the number of live objects in the memory. Given also how our programming model is structured, anything more than 4 megabytes is practically useless. You will never see the garbage collection running. You will see it like once a month. And it will run on a, I'm giving you some numbers, on a ARM9, 100 megahertz, 4 megabytes of RAM, the Atmel SM9. I saw it running for 40 to 50 milliseconds, which is not noticeable already, but you don't want to go beyond that limit. So my answer is, it's useless to have more than 4 megabytes, but there is no upper limit.
What about media playback and codecs? Kind of like the smooth streaming from IIS 7?
We have been debating over the first 3 or 4 years of the micro frameworks whether we should make it a platform for embedded in general, for industrial automation, for consumer devices, and we never took a decision. We're leaving that decision to our customers. So we do not support any codecs, which are typically consumer-related, for consumer-related products, but we have several partners that actually do. And that is a very easy driver that you can add with the porting kit and expose in the object model using interoperability. So I would go and look with our partners like GHI and Device Solution and the Bluffing guys that are distributing the board through Avnet, what they have available already. And if you are not satisfied, I would download the porting kit in GCC.
Cool, thanks.
You're welcome. If there are no other questions, I thank you very much for coming, and we have a booth. Thank you. We do have a booth in the main room, the VN04, with the DevDiv guys, and please stop by. We are giving away boards, and there is a lot of interesting hardware to take a look at. And please go on microsoftpdc.com and leave feedback about the presentation. Thank you.